In this video, we're going to use our trig skills to figure out the angle here, because we have some requirements here. First of all, we figured the height of this tree was 57 feet, and this is going to be like a 40-meter inverted V. And 40-meter dipole, I think, is about 67 feet across. So that's going to be, about 33 and a half feet per element here. I'm just going to round this to 33. That's not critical. We just know that it's going to be shorter than what can be attached to the ground. So I have terminators here, and this is guy wire or something attaching it to the ground. Now, what we have to be careful of is the vertex angle here at the top. It has to be, shouldn't be any less than 90 degrees. So our vertex then has to be greater than 90 degrees. And the reason being is that the magnetic and electrical properties of the signal that are on the elements, if it's less than 90 degrees, then they start interfering with one another and the performance of the antenna degrades. So what we want to do then, our basic problem is, how far away do I get from the base of the tree to put the stake in the ground or wherever I'm going to tie this off to? That's what we don't know. Well, we've already set that we need the vertex greater than 90 degrees. So that means then, and just dividing this in half as to two right triangles here, this has to be greater than 45 degrees. Or, greater than or equal to. Let's actually set it to 46 degrees. That way we're guaranteed to have something a little bit larger than 90 degrees up here. And again, this is a right triangle. So this is our angle of interest here. So if we come across here, straight out from there, we run into this side over here. This is our side opposite. This is our hypotenuse. And this is our side adjacent. So let's resurrect our SOHCAHTOA. SOHCAHTOA. Sine, cosine, tangent. And I sure didn't do a very good job on the toe, did I? Okay, SOHCAHTOA. Alright, so this is the opposite over the hypotenuse, the adjacent over the hypotenuse, and the opposite over the adjacent. So which one do I use? Well, which of these three functions deals with the side adjacent, because I know it. The height of the tree is 57 feet, and x is the side that I'm trying to know down here. So that's going to be the tangent. The tangent of this angle. I can determine what this distance is. So the tangent then of 46 degrees, because we've set that to be 46, is equal to the side opposite, which is x, over the height of our tree, which is 57 feet. So isolating x, we'll multiply both sides by that 57. Those cancel. So 57 times the tangent of 46 degrees will tell me in feet what this side is. So let's turn on the calculator over here. And the other thing you want to know on your calculator is make sure that in its mode it's set to degree mode and not radian. They're not even close. It's about 57 point something degrees in 1 radian. Radians are handy for calculus. But for backyard trigonometry, we need degrees. So let's put in 57 times the tangent 46 degrees. And we see then that this side opposite has to be no less than 59 feet. Matter of fact, we could round it up and say, let's set our stakes out here at 60 feet for our guy wire. That will give us a vertex angle guaranteed to be greater than 90 degrees. And that's where we'll attach. All right. So there's another way of using what you learned in trig to solve a practical problem in stringing up a wire antenna or whatever it is out in the backyard. Have fun.